Thank you. So hello, everyone. We wanted to present to you a new Spark connector that we wrote and we open sourced, and we call it Adaptive File Source Connector. So first, a little bit about myself. My name is Sharoni. I'm a software engineer and team lead at Hunters AI. I've been there for the past 2 years. And I specialize in machine learning and big data. And for the past 7 years, I've been working for different security product solutions, from enterprise security products to web application firewall, fraud detection. So I've seen many different solutions. And fun fact about myself, I started out actually as a hardware engineer.
My name is Wojciech Indyk. I have been working on big data topics for over 10 years, and data science as well. I have published 11 papers regarding distributed machine learning system, and I need to say I love open source.
Cool, so first a little bit. You have to turn it on. You have to turn it on. Yeah. So a little bit about Hunters. So we are a security operations platform, which basically means we help security teams to discover cybersecurity attacks in real time, and also mitigate the attacks and understand what is actually happening inside their networks. And we do that by first ingesting all the different security products that there are. And so, right, like every chief security officer in an organization usually has like between 20 to 50 different security products that he needs to manage and maintain. And so these products are scattered all over different facets. Could be network, endpoint, right, like antivirus, like Kaspersky, or all sorts of antiviruses. Could be cloud, AWS, Azure, SaaS applications like Salesforce, email, etc. And the problem with all of these security products is that every security product is actually looking at a very small slice of the world. So you see here below a simple attack chain that an attacker, it might take him 2 weeks to start it out. So he can start out by infecting a certain device, might be an employee's device, with a small piece of malware. Afterwards, after he infected that small piece of code, it doesn't mean that he has full capability. Maybe he will need to download some more payloads from the internet. That might look a little bit weird. Afterwards, he would need to persist on the machine, right? Like live through restarts, also evade the antivirus installed on the machine. That would also look a little bit weird. And maybe afterwards, he will want to navigate to a different computer, right? Like usually the most interesting computers in the network are the IT guys or the HR computers. So he will need to command over this malware. So he'll probably need external communication from the organization outside. That communication may also look a little bit weird. And once he's moving from one machine to another, in the end, he may reach an asset which he can monetize, right? Like a database which holds some very sensitive data. Then he will need to exploit this data out, right? And now uploading a lot of data outside the organization may also look a little bit weird compared to the regular network traffic you can see in the organization. Now, all of these small things, that I've told you right here, it's very difficult to detect them with high certainty. And all of these security products, one of the main issues is that they have high rates of false alarms. And so think about it, like a lot of blipping sensors, and it's really hard to understand from these blipping sensors the whole picture. Okay, no, this and this and this and this, they all are actually connected, and it's an attack. So basically, what we do is that we ingest all of these security data, and we run on top of it. So you can see here an example, right? Like different security data that is being ingested and how it all connects. We'll get to that later. And this is how our pipeline actually looks like. So in the end, again, we have so many different security products, and every type of product, it has so many different vendors. And the teams that actually define how those security logs look like, they do whatever they want. So it can come in all different formats, all different sources, can come from APIs, from Kafka, from storages like S3, Azure Blob Storage, and we need to be agnostic to that. We need to ingest all of that. So we have a smart ingestion layer that is based on Spark, and it's ingesting all the data to a data lake. So currently we only run for a Snowflake data lake, but we will eventually also support Databricks Delta Lake. And afterwards, there's a Flink-based detection layer that is running in real time. And it's basically detecting all of those small scratches that I told you about. And we call them leads. And so these are written to Kafka. And from there, there's a cascading set of microservices that are actually doing some more querying and more enrichment, right? Like suppose that I detected something weird that has happened on Ada's Sharoni's laptop coming from this IP. So I might ask, okay, so what else have I seen Ada Sharoni doing, right? Like, does she have more accounts? What else has come out of this IP? So I can ask more of these questions. And in the end, once we figure out everything that is relevant, everything has been thrown into a graph database, where there we correlate everything, and we figure out, okay, so this and this and that, together, this is the full attack story. And everything needs to actually get updated in real time. And our customers are actually expecting us to detect and update this image in a matter of minutes from the moment that these scratches have even started. So the reason why we all came here, right? So the problem that we face was that around 50% of the security data that we are actually working with, they get shipped to S3, for instance, or to a regular object store. And the problem, for us at least, is that the S3 buckets, they don't belong to us, they belong to our customers. And our customers are often using them for all different purposes. And oftentimes they just use it for audit and they keep the data for years. So these buckets are actually huge. And for some of our customers, actually, it's like to list the entire bucket, it takes like 24 hours. And so again, like as I mentioned before, we need to detect these attacks in real time, right? So we need to use streaming. Now, unfortunately, S3 is not HDFS. Okay, as an object store, the listing itself, it's proportionate to the size of the bucket. So again, as I've mentioned, for some of our customers, it can take 24 hours to list it. So it's fairly difficult if we want to detect new files in real time. And also these operations, the listing itself can cost a lot of money for our customers if it's in their S3 bucket. And there are existing solutions, right? You can see here there's an open source by Quabble that is actually, it requires, you can see here, it requires you to configure S3 events on the S3 bucket and direct it to a queue, right, an SQS queue in this case. And then there's a Spark connector that can read the messages from SQS, understand that there are new files from SQS, and then ingest it from S3. And so there's also a similar managed solution by Databricks Autoloader. Now the problem with these solutions are that, at least for our customers, setting up S3 events, sometimes it makes the whole process more cumbersome. And a lot of our customers, they struggle to do that. And also, like, we could have just said, you know what, just give us high permissions and we'll set everything up for you. We'll set these S3 events for you. Now, a lot of our customers, they don't want to do that. It's sensitive data, and they're not willing to give us the authority to do that.
So now you can ask, how can I stream data from S3 bucket? And let's take a look how Spark does it natively. So in the middle part of this diagram, you can see file stream source that is calling S3 client with the method fetch all files. And then S3 client returns all the metadata about listed files, make it through the SYN fail cache, and then all the unseen files are stored in metadata log, and they are persisted to be checkpointed. And the problem is, fetch all files function. As Ada already mentioned, fetching all metadata from object store is a huge cost and time. Besides, this solution is not scalable. All of the metadata needs to go through the driver that is just single instance. So when S3 bucket is growing, there is a problem of computation on just one single node. So how we can tackle this problem? We took a look about how the directories that we are listing looks like. So most of them related to time series data, like logs in our case, looks like first, name of object store, S3 here. Then some metadata, bucket name, account, service name. And the last part is about time dimension. In this case, year, month, and day. As you may already noticed, this part about time is dynamic. That means it changes when the new data are coming in the next day or so. So then we had an idea that we know our paths. There is a part that is static about metadata and known upfront, and the dynamic part about time dimension, but still we know how it should look like. So basically we can generate it. And you can ask, why? Let's imagine we have large bucket. We made an experiment to get all files, just metadata, listed that files from the large bucket for a few years of data. And that listing took us about 24 hours for all the data we had. Then, when we reduced the query for just 1 month, it took 2 hours. And then you can imagine, if you shrink to 1 day, it will be at about 2 minutes. And the main point here is, when you use streaming, then you usually need just most recent data that is about 1 or 2 days, maybe. So let's take a quick recap. If you are using Spark streaming and you know your structure of your S3 path, and you have a dynamically changing part in your paths, so for example, time dimension of data that are partitioned by day, then you should definitely pay attention to our adaptive Spark connector. So now, how it looks like. You can see very similar diagram like that I shown you before, and the middle part is a little bit different. Now it's dynamic. So we changed the function of calling S3 client. Now we fetch files, but we provide as an argument generated paths that we want to list. So how it helps? It first lists only necessary paths, that is, in our case, 1 or 2 days. And the second thing is, now the solution is scalable. We call fixed number of paths. That means our driver can safely process all the metadata in regular, similar time. So how you can use it? It's actually pretty simple. On the top part, you can see our adaptive solution connector. And on the bottom part, there is a native solution that is very similar to our one. So what you need to do in our case, you need to put a format like dynamic path files. Then you need to provide file format that you need to read. And we support actually all file formats that are used by Spark. So for example, JSON, CSV, text, and the others. And then at the end, on the load function, you provide a path, just very similar path like you use in native solution, but you have a place for wildcards of year, month, and day. And if you do that, that's it. But what if year, month, day is not enough to you? You need to extend it, but don't worry, it's still pretty simple. Here is an interface of path generator that you need to provide set of paths you need to list at particular time when you create your microbatch. So let me give you an example of our dynamic path generator that we already implemented in our solution. So you need to provide parameters like wildcarded globe that is similar to what Spark Native gives you, plus enriched with our placeholders for year, month, and day. Then you need to define how many days you want to query in your function. By default, it's 2 days. And there is time zone, last but not least. So let's imagine an example that we are in San Francisco and there is 10 p.m. today. In Central Europe, it's 7 a.m. next day. And if we are processing the data in San Francisco on servers that are set to this time zone, and the data are coming from Europe, then data from Europe are already saved in the next day directory. And we in San Francisco believe it's still today, so if we provide the time zone, we can safely process the next data from Europe. Okay. Enough to talk about technical things. Let's see how it works. So, first of all, I would like to show you the data that we are processing. So, basically, like I said, we have a bucket that is a test data, and it has got some metadata plus the time dimension on the end, like year, month, and day. So, in our test bucket, we have a bunch of JSON files that are small files, but there are plenty of this, like you can see here, and they are related to AWS CloudTrail. Then, how the native solution of Spark works here. You can see its job running for 7.4 hours. There is no jobs on the list. That means no data were processed yet in the native Spark. Why? Now you can see list get offset is the function that take all of the time for native solution. That means we spend all of the time just on listing of our paths. Again, you can see nothing on the job list, no data were processed. So how our adaptive file source works here? You can see the snapshot of time 25 minutes from start, and you can see a lot of data were processed already. It looks different. The brown part is about listing files. Now it takes about 1 or 2 seconds, depends on data that are there. We process some data on the first and the second microbatch. Then you can see the flat brown, that is no data are coming, but we still need to list our paths. But it takes only 1 or 2 seconds, so it's very, very good in compared to the native one. Then again, we need to wait for some new data. Now we have some data, but most of the time is just about processing time. That is super cool. And then again, no data and some of data are coming. It's very efficient in our case. And if you have more and more data, then the bar that is yellow regarding to processing will grow up. And the bar that is brown about the listing files and fetching where we are with files will be still at the very similar level. So now you can ask the question, how actually it helps our business.
So as Wojciech have seen, so this data is AWS CloudTrail, which is audit log for the cloud. And so you can see there anything weird that has happened in the cloud logs. And just like that, so we have this source connector, right? It's streaming in live, and we enable our customers to configure all of their data sources through our portal. So as you can see here, like there's a variety, again, of different security products. And once they get everything ingested in real time, so you can see here, right, there's multiple, like there's antivirus over there, CrowdStrike, there's email, Proofpoint. And so we're talking about, for our customers, petabytes of data. This one's it's actually a lab account. And what you can see here is actually live, that there is an attacker that is actually attacking through this, in this lab account. And so everything here behind the scenes, actually, it's real. So over to the left pane, that's the time dimension. And these are those weird scratches that I told you about. So you can see over there, there's a weird email attachment that has been pressed by an employee, Larry Miller. Afterwards, there's a weird behavior seen by the antivirus. So there's like a PowerShell command that the attacker must have used in order to use Windows operating system and evade it. And afterwards, you can see a weird DNS request, perhaps to the command and control server that I told you about. And later on, in the end, you can see that there is actually some weird behavior that this user is actually trying to access, to assume a certain role in AWS, which is highly privileged, which is also kind of weird. And again, all of these scratches, they come from different data sources. And they actually, you can see here that they all connect because the email, Larry Miller, is actually connected with this host. And you can see lots of connections that have actually, all of this entire picture actually gets updated in real time. And so the source connector that we've just presented to you is what's been helpful in order to make that work.
Okay, so now the good news is that we actually open source this project. So we want to encourage you to join the project. And we just presented one application in our cybersecurity industry, but we believe that it might be applicable in many other industries. So if you feel there is some overlap of the problem we presented on your problem, that will definitely make a match, and we are very happy to talk to you about how can you use this one and how we can go with this project to be better and better, because we can see a lot of room to improvement here. We will present on the next slide. So here is the roadmap of the project. First, we think that that fixed solution of year, month, and day might be not enough. So we would like to give everyone a chance to define any time dimension on second resolution or any time dimension that Spark supports. Then we need to provide a firm path that for some times might be a little bit hard to just use, because you might get a particular directory that you don't want to list, and then blacklisting would be a very nice feature to do that. The third point is we have got some metadata on our paths on S3, so we think we may use this metadata as new columns, so this is also on our roadmap. Then we talked about S3 a lot, but there are a lot of more object store than S3. So we believe we can try against either Azure Blob Store or Google Cloud Store or many others. So we feel that here we have also a big field for collaboration with you. And again, we encourage you to approach us, and maybe we will do something big. And last one is very Spark-oriented. As you probably know, there are 2 versions of data sources for Spark. We implemented this solution in version 1. Now there is version 2 that has got a lot of nice features. For example, continuous processing mode that we would like to utilize. So finally, we would like to migrate from Spark data source version 1 to Spark data source version 2. So we have just 5 main points to improve this project. So we believe after this talk, we would add a few more after the conversation. And for now, that's it. Thank you very much for your talk. Any questions?
Hey, great talk. So have you considered the option to use epoch patterns for the folders instead of using dates as you just did, year, month, and day? It means when you have epoch, you will be able to set a different level of fragmentation. It means you can do it daily, hourly, or minute level instead of use subdirectories.
So if I...
Yeah, what you see in here is the structure. This is like a AWS CloudTrail structure. Yeah, like as Wojciech mentioned, we need to extend it and like into supporting other formats as well. It really depends on what the developers of the security products really, in our case, what they thought to themselves and how they structured the path. But yeah, definitely.
Thank you.
I was slightly confused about like the file cache and exactly why that was needed. But I guess as a follow-up to that, did you need to do any like reconciliation for late data?
Excuse me, I didn't hear the question.
Can you repeat the end of it?
My main question is like, do you have to do reconciliation for if late data were to arrive at a partition that you've already scanned? Like, do you do hourly and daily like full table scans and then kind of like diff to see if you lost a file, for instance?
So you're right. In general, it's a whole entire issue of like late arrivals. Specifically, we don't ingest late arrivals, but it's completely it's something that can be extended.
Hi, thanks for the talk. Do you have any plans or have you thought about expanding the connector to be compatible with other cloud providers? Like, I don't know if the same problem exists in like Google Cloud Storage, or I don't know what the Azure equivalent would be.
Yeah, it does.
But
yeah, that's what Wojciech said, that it's on our roadmap. Yeah, definitely. But and we know that it's also an issue there.
Okay, cool. Thanks.
You've probably thought of this, but I figured I'd mention it. Have you considered sort of extending your month, day, year pattern to the more general, something like the Java date time pattern symbols, so that it could be even more flexible?
And I didn't hear it, sorry.
Yeah, did we think about extending it to more different types of patterns?
Yes, definitely. Like we started from time dimension pattern, so we have on first row of our roadmap to support any time configuration, time pattern that Spark supports. So basically, it's based on Java patterns that is very flexible. So that's one point. But I can imagine like there might be another dynamic part in your path, not related just about time. So yes, definitely the structure of the project is composed in a way that you can build your own generator. So we build our the generator based on time. You can build your the generator based on something else. For now, we don't have any different case than time dimension, so that we don't have it on our roadmap, but when it will appear, definitely we'll consider that. And we believe it should be fairly easy with the structure we have in the project.
Thank you.
Thank you, everyone. And also, if you want to afterwards ask us personal questions, we're also here. Thank you.